Today I will discuss about the control strategies of the duty cycle. So in case of the DC to DC converter, we know that it is used a fixed DC voltage to convert it through the DC to DC converter into variable voltage of the DC. So how it is possible? So today I will discuss about how it is possible to get fixed DC voltage to variable DC voltage. We know that in case of the boost converter or buck converter, the output equation, like in case of the boost converter, V0 is equal to Vs by 1 minus D. It is the output equation of the boost converter. In case of the buck converter, we know that the output equation is equal to V0 is equal to Vs into T. Okay, so that means the output voltage can be varied by the duty cycle. If the duty cycle value is changed, that we can easily get the output voltage value also change. So it can be controlled by two schemes. First is time ratio control and second is current limit control. In time ratio control, we know that the duty cycle value which is as a ratio of the on time divided by the total time of switching. Okay. So the time ratio control can be controlled by the two ways. Either it is a PWM technique or is a FMC technique. So in case of the PWM technique, we know that in case of the PWM technique, which is known as the pulse width modulation technique, where the on time is varied keeping the frequency or time period T constant. That means in case of the duty cycle, the duty cycle value is is a ratio of the on time divided by the total time. Okay, so in case of the PWM, we can vary the on time of the switching operation, but the total time is remain same. Let me give an example. Suppose the total time is a 60 seconds. Okay, in fast switching operation, we are using the on time is equal to 20 seconds. So the duty cycle value is now 20 by 60. That means 1 by 3. If this value we will put in our output equation of the boost or buck converter, we can see the output voltage value maybe in suppose the input voltage value is a 100 volt. So the output voltage value will be calculated by the equation of the V0 is equal to Vs by 1 minus D. We can easily get that approx 300 respectively, write that. Okay, so next cycle we can change that T on time, but the total time will remain fixed. That means the total time is a 60 second, but the on time previously we will use 20 second, now we will use 40 second. That means the duty cycle value equals to 40 by 60. That means 2 by 3. If we put this equation in the buck converter output equation, that is V0 is equal to Vs into duty cycle. That means if suppose your input voltage is 100 volt, that means that your output voltage V0 is equal to 100 into 2 by 3. That means 200 by 3, which is equals to 80, near about I think near about 67 value. Okay, but if you use that first term 1 by 3, in case of the output equation of the buck converter, we will get 33.33 volt. So we can say after the changing the on time of the switching value, we will get the variation of the output voltage level. Okay, so here the two picture is say that two cases, the duty cycle K value is one cases is 25 and other cases is 75. So that first case is where we are using the K value is equal to 0.25. So we can see that output the total time is equal to T, and the on time and off time we can easily seen from this visual. Okay, then the next cycle we are using k is equal to 0.75. That means the on time and off time is varied. So that's why the load voltage value also vary through this graph portion. The next is a variable frequency operation. So in this control strategy, the frequency or the total time of the switching can be varied, where the on time or off time will remain constant. So it is called the FMC control. That means frequency modulation control. Here we also use the total time will be varied. For suppose we first cases we using the total time equals to 60 seconds. In second cases we will use the total time is equal to 80 seconds. But the on time or off time will remain constant. In first cases the on time is 20 seconds. In second cases also the on time is 20 seconds. So we will get the ratio 1/3 and 1/4 respectively from the duty cycle equation, where the T1/T, that means 20/60 in first cases, and second cases 20/80, that means 1/3 1/4. If we put the in equation of the buck converter, so we can easily get the output voltage level, where V0 is equal to Vs into D, where Vs is equal to 100 volt. That means in first cases we will get 33.33 volt. In second cases when we put 1/4 ratio, that means 25 volt. So we can easily see that the value of the duty cycle is effect on the output voltage of this two converter, either shift boost or buck. Okay, so this is the graph form. Okay, that is the on time and that is the total time. So after that changing of the on time and off time total time, we can easily the value of the changes we can see, where the T is a variable terms and then T on is a fixed value. Okay, in second cases we also give an example of the off time also, so you can see that things from this two graph. Okay, the next is a current limit control. So in case of the current limit control, as can be observed from the current waveform, for the types of DC to DC converter,